Okay, so let's look at the temperature structure a little bit beyond the stratosphere. You see some interesting features here. So in the troposphere and lower stratosphere, basically look like there was some sort of a symmetry around the equator towards the poles. But once you go beyond that into the upper stratosphere and into the mesosphere, so here we have stratopause and then mesopause, and then we have thermosphere here, and so on. And here is our familiar structure with the tropopause being at a higher altitude. This is the altitude here in kilometers than at higher latitudes. Obviously, if you remember our temperature structures, the tropopause is at 12 to 15 kilometers in the low latitudes, whereas as you go to higher latitudes, temperatures get colder, so the atmosphere's tropospheric volume is decreased because it's denser and colder. So the tropopause drops off, and there is a gap here in the subtropical region. So there is some kind of a discontinuity in the tropopause. Okay, we'll see that in the wind structure a little bit later on, and we will explain its dynamics in the coming chapters. Okay, but the only point to make here would be that if you are trying to move vertically from the ground into the upper troposphere and into the stratosphere, then you have to get through the tropopause here. So you'll have to change your properties to get across that inversion of decreasing temperature to increasing temperature. Okay, so its motion is slower here, and you need energy to puncture through the tropopause into the stratosphere, whereas along these gaps you can move almost horizontally and come out on the other side. So this tropopause gap has some dynamical significance as well. And you can see some cross-equatorial kind of structures here that are not there in the temperature structure below the lower stratosphere. So we'll also see this. This is for the boreal northern summer solstice. So this whole thing will change with the season. Okay, so it's beginning to rain here. A cyclone, a mini cyclone, a low pressure system is coming, and things are going to explode soon. But nonetheless, let me proceed a little bit with the concept of geopotential height. I think you can already get a sense of where we are going with it. We start with our hydrostatic balance, dP dz equals minus rho g, where we replaced rho with ideal gas law by P over RT. And we're going to invert it and write it as dz over dp is equal to minus RT over GP. All we did is just invert this relation. Obviously, you see our familiar way to do things. You move the P over here, and you can get P d dp as d over d ln P, right? Some people call this dou, but I'm just going to say d, right? Partial differential. Once you have that, you can write this as dz d ln P, we have taken P here, is minus RT over G. What is minus RT over G? This is our scale height, right? So going from the hydrostatic relation, we have inverted the relation, and we're writing the variation of height as a function of pressure in terms of the scale height that we had talked about before. Remember, scale height is something where a variable drops off by one exponential, or it's the e-folding height or e-folding depth. Okay? We'll take this a little bit further with the derivation in the next podcast, but just remember this tropopause gap, which is important, and geopotential height definition is going to basically come out of this relation between geometrical height from the surface and pressure variations in height from the surface. We will see that we said hydrostatic pressure tells us that pressure at a particular height is related to the mass of the air above, and we'll see that the geopotential height is related to the temperature of the air below. So mass above gives you pressure. Geopotential height is related to the temperature of the air below. So we'll continue that in the next podcast. Geopotential height is a very important concept used heavily in atmospheric science. It has dynamical significance and allows us to describe weather, especially in terms of geopotential height. So that's why it's important to understand it.